So we achieve the ordinate is of 7.262 and this ordinate 5.84, this 5.84 which is over here at 1 meter, joining all these points by cubic parabola plus, and this is of 7.262, this is of 5.84. So how we have plotted the bending moment diagram, it is clearly visualized for a given beam subjected to the UVL on the half portion and no load in this particular region, shown over here. So I wish it is easily understood to you how this diagram has been plotted. So let us go for the next problem. Carefully visualized for a given problem. Combination of load. Now let us take a combination of load. All the three, see here, three combination: UVL, concentrated moment, and UDL. The three combinations has been taken care in this particular beam. The first 3 meter region UVL is there, the next 2 meter region UDL is there, and at this junction the concentrated moment is acting. So now let us found out the step number 1 is support reactions. Our intention is to find out the support reaction first. Before we found out the support reactions, let us modify the figure and converted this UDL in terms of the equivalent point loads and UDL in terms of the equivalent point load. This is half into 20 into 3 acting at the CG, that distance of 1/3 into 3. This 10 into 2 UDL acting at the CG. CG is the center point, exact the center point of the UDL. At this A, RAH and RAV both are the reactions acting. Taking sigma H is equal to 0, we will obtain RAH is equal to 0. Taking sigma V is equal to 0, we will achieve RAV and RB both are upward, hence RAV plus RB is equal to total download, that is half into 20 into 3 plus 10 into 2. The summation of both, that is 30 plus 20, that is of 50 kilonewton. There is no contribution of this concentrated moment on sigma V. See over here, RAV plus RB is equal to 50 kilonewton and there is no contribution of concentrated moment. So these equations gives us the combination of RAV and RB. Our intention is to find out individual what is the value of RAV and individual value of RB. To find out that, I have to take a moment at a certain location. Let us take that location at A. Sigma MA is equal to 0. Refer the figure. Sigma MA is equal to 0. So first load, that is of UVL, because RAV, if you take the moment because of RAV at this point, it is obviously 0 because the moment acting at a point at which the force is acting. So first load half into 20 into 3, create a moment, that is half into 20 into 3 into 1/3 into 3 is the moment, clockwise moment, hence the plus sign. So see the next one, half into 20 into 3 into 1/3 into 3. Next, concentrated moment is acting and which is of anti-clockwise direction, hence negative sign minus 20. Next, UDL 10 into 2 into distance from A, that is 3 plus 2 by 2. This creates clockwise moment, hence positive, while RB creates anti-clockwise moment, hence minus RB into 5 is equal to 0. By simplifying this equation, we achieve RB as 18 kilonewton. By putting the value of RB in this equation, we achieve RAV is equal to 50 minus 18 is equal to 32 kilonewton. So, using the three equilibrium condition, it is very easy for us to find out the support reactions. So, next step is to plotting of shear force diagram. Now, let us plot the variation of shear force diagram along the length of the beam. Important point is us. First, within this 3 meter region, UVL is there, hence the variation is of parabola, and for the last 2 meter length it is of UDL, variation of is of inclined straight line, and there is no effect directly on the shear force diagram of this 20 kilonewton into meter. There is no effect over here. Now let us plot over here right now in this case. This is a given beam. Three meter UVL is acting. Anti-clockwise concentrated moment is acting, and UDL is acting. The magnitude are this is of 20, 3 meter. I think that this is 10 or 20. I think it is 20. Yes, it is of 20. This value is of 20. This is of 10. Now, reaction RA, we got it 18, and RB we got it 32. Let us check it out. No, this is of 18 and this is of 32. So we got RA is of 32 and RB is of 18. See the previous case that we have found out the reactions. See the previous case on the slide. We got it RB as 18 and RA as 32, and if we see the previous figure also, this value of ordinate is of 20. So 20, 20 and 10. There's 3 loads are there. Now let us come over here. This is of 32 is the ordinate. So shear force at A is equal to, if this is given as point A, plus 32 kilonewton. This is my B point, this is the C point. Shear force at C is equal to 32 minus half into 20 into 3, that is of 2 kilonewton. So this ordinate is of 2, but question, how to join this ordinate? Should I join by this parabola or should I join by this parabola? Should I take this or this is the important for me. To find out this, let us take a point 1.5 meter. I have to take 1.5 meter. I have to find out this ordinate. So for that I have to take this 1 meter, 10 kilonewton per meter, 20 kilonewton per meter, and my shear force at 1.5 is equal to 32 minus 10 into 1 minus half into 10 into 1. What I did? I divide into two parts. This is the UDL. This part is of UVL. So finally I achieve 32 minus 10 minus 5, and that is nothing but 32 minus 15 comes to be 17 kilonewton. So now carefully visualized, if I will adopt a center line as a straight line, if I will adopt these as a center line, then the central value of ordinate 1.5, because this is 32, zoom once again right now over here, this is 2. So if we go for this central ordinate, then this ordinate must be how much? 32 is there, 2 is there, difference is of 30. This ordinate must be of 20. So our ordinate is of 17. So this diagram is of below the inclined straight line. Got the point? Why we have chosen this below diagram? Next, this is of UDL, SFB is of 18. So this ordinate is of 18, and this is joined by inclined straight line. So visualize the point at which the shear force is 0. It is the region between C and B, and we have to find out the distance x by using pure mathematics, using the equating the triangles. We found out this value, or by taking a section between C and B, we have to write an equation of shear force at a section XX which is equated with 0, and we have to find out the value of x. So we found out the value of x is of 1.8 meter. So please refer the figure over here. This is the parabolic nature, the value of ordinate 2 at this concentrated moment, and then the diagram changes its sign from plus to minus, from 2 to 18. The point at which the shear force is 0, that is of 1.8 meter from B. Now let us plot the bending moment diagram. Now visualize the value of bending moments are 0 at its supports. The given load between A and C is of UVL, hence the variation of bending moment between A and C of nature of cubic parabola. Then concentrated moment is there, So either sudden drop or sudden rise, sudden change in the bending moment diagram is possible, and then between C to B this diagram changes of parabolic nature. So let us we plot this diagram over here right now. So let us we found out what is the value of bending moment at C point on just left of C. 20 kilonewton per meter. This moment, concentrated moment, which is of value given is of 20 kilonewton into meter, and UDL is of 20 kilonewton per meter. So bending moment at C point, if we will take just left of C, use the word just left, then in that case this RA into 3 minus half into 20 into 3 into CG distance is over here, and at this is my perpendicular distance, 2/3 into 3. The value of RA is known to us as 32. Simplify this equation, we achieve as 30 kilonewton into meter. This value is on the just left of C. If I will go just right of C, I have to use the value of 20. And the important thing is there, if I will take a section left, anti-clockwise nature of moment creates hogging nature, that is of minus sign. So bending moment at C just right is equal to this 36 minus 20 is equal to 16 kilonewton into meter. This variation we can obtain. See the figure over here.